Okay, good evening, everyone. In the last session, we had discussed about the Hadoop MapReduce framework. So Hadoop MapReduce framework is designed to process large amount of information, or we can say big data. So there are challenges with big data. First challenge is processing. How can we process a large amount of information? And second challenge is storage. So Hadoop MapReduce framework will provide solution for processing and as well as challenging storage of information. Hadoop MapReduce is work on the distributed environment, and it uses commodity computers for processing as well as storage. So it will have a large data set as an input. It will divide those data set into a smaller section, a smaller subset, and these subsets are assigned to different computers. Again, if we provide a task to the Hadoop MapReduce framework, then this task will be divided into subtasks, and this subtask is assigned to commodity computers in a distributed environment. Then we had discussed about the Hadoop distributed file system. SDFS is designed to store the information. So it will follow the same structure like directory and files system as available with the native file system. But it has a different features compared to the native file system. It is basically designed to process large chunk of information. So there again some challenges when we are storing such a large amount of information. First challenge is uh, accessing those information. So when we store the large amount of information, so it is challenging to find out the required information in minimum time. As the compute storage system will work, it will take your query and based on the query input, it will search in the storage files. Now, second challenge is fault tolerance. So as we have already discussed that Hadoop MapReduce system is designed to be fault tolerant. It means it will give us to immunity against any human field intervention. Suppose a human has done some intensely or non-intensely has done some wrong with the system. Second, suppose any natural disaster has occurred and this disaster has created chaos with the system as well as the physical damage to the system. And third one is if there any device failure or software fault will occur within the system. In all this scenario, there is a possibility that a device can be uh, down for some time and it will lead to loss of data as well as loss of computing time. So HDFS will take care of all these things and it will handle the data efficiently. So in any case of failure, it will have a backup data and it will take the help of those data. Then we have discussed about the mapper and reducer. So basically mapper will take the input data set and it will distribute the data set between the different devices. We call those devices as a slave. And reducer will take the various output which is generated from these devices, and at the last of the processing, it will combine those output and return back to the mapper. Now, in this section, we'll go further with the Hadoop MapReduce system. So this diagram is representing the component within the Hadoop map ecosystem. So you can see that in the bottom of this system, there is a file system that is Hadoop distributed file system, which is SDFS. Then on the top of SDFS, MapReduce framework is designed. So it is basically distributed processing framework. And by using the MapReduce framework, there are various interfaces and framework designed to process the different kinds of data set. So these are Hive, R, Mahout, Pig, and Nuzul. So you can find out there are certain component which is covering from bottom to top. So these are you basically using the Hadoop MapReduce framework, but they have do some customization based on their requirement. Now, so let us go proceed. So Apache Hadoop consists of two sub projects. First one is a Hadoop MapReduce. So as we have discussed, MapReduce is a computational model and software framework for writing application. So these applications are designed to run basically run on the Hadoop MapReduce framework. So whatever the computational requirement for the Hadoop MapReduce framework will be taken care by the MapReduce, and this is basically a software framework, and it is written in Java programming language. So when you want to interact with the MapReduce, you should have a knowledge of Java programming language. These MapReduce programs are capable of processing enormous amount of data in parallel and distributed environment. So when we are working with a MapReduce, basically we'll take number of computer systems and will assign those computer systems different computing tasks, as well as we'll assign them a data set. Now, based on the data set and computing task, these computing system will work on their given task. So, in this way, what it will do, it will take the scale of large scale of computing node to increase the processing capability of a distributed computing system. So whenever we are writing a program for MapReduce, so it is able to handle the large amount of information due to its nature of distributed nature, as well as parallel computing environment. Now, second part of Hadoop MapReduce is the SDFS. So we have discussed a few points about the SDFS. Now we'll take some brief overview about it. So basically, SDFS is designed to handle the storage for Hadoop applications. So storage means when you will pass your data set to the SDFS, then it will take care of each and everything, storage of those information, distributing the information among the different devices. MapReduce application are designed to interact with the SDFS. So whenever you have an application, you require some data to process by the application for any desired outcome. So MapReduce is designed such that, or when you are designing your application for MapReduce framework, so you will design your application such that it will interact with the SDFS, and it will pass the data and to the data to the SDFS. SDFS basically create a same replica of data blocks and distribute these data blocks, same replica of data blocks between the different computing nodes. So what it does, basically, when you have a same data set and you will distribute this data block to different nodes, then what happened? Basically, you are avoiding any chance of failure of loss of data. So, as we have already discussed, there are various challenges with the big data. One of them is loss of data due to fault or loss of information due to any human error. So, HDFS will try to overcome this problem by creating a replicas of data. It will enable the MapReduce framework to be reliable and fasting with having a fasting computation capability. So as you know that if you are handling your data, big data with the HDFS, then you have COT that whatever the data you have with the HDFS, that data will not going to be lost. And HDFS has its internal mechanism which will take care of all the data set by dividing the data blocks in and distribute them to the different computing system as well as creating their replica and distribute to the different system. So any human error or any natural disaster will not have any adverse effect on your big data. Hadoop is basically known for the MapReduce and SDFS, but it is also related to the family of project. And these projects are included well-known Hive, HBase, Disco, Flow, and Juki. So for the assignment purpose, you should write over a brief overview about these different Hadoop related projects. So write down the overview as well as write the advantage and disadvantage and in which type of application or scenario these projects are having their applicability. Now, let us discuss about the Hadoop architecture. So, as we have already discussed, Hadoop MapReduce is made of two parts. One is a map producer and one is a SDF. So, basically, map producer will divide work on the master and slave node. So, first understand what is a master node and what is a slave node. When you're having a number of system, then you can select one of the system as a centralized system and all other system will work as a support system. So this centralized system, the task with the centralized system is to have continuous monitoring of all the support system as well as assigning the task to the support system, assigning to the job to the support system, and keep the monitoring of status of all the job that is being done. And when the job will be finished, it will take the result, take the output from the support system, and when it will receive the output from each and every system, then it will compile the output and will represent to the Hadoop MapReduce framework. So in MapReduce, we call this centralized system as a master node and this support system as a slave node. So there can be any number of slave node, but there should be a single master node. Okay, so basically the job of the master node is to have the monitoring and controlling of the information, and the job of slave node is to have to finish the allocated job and respond the every query which is being generated from master node. SDFS layer is responsible for storage of data. So basically, it will have, again, it will work between the master and slave node. So basically, master node is responsibility is to have the data set, divide the data set into data blocks, and will assign to different slave node. And again create a replica of these data blocks and will assign to the various slave node. All these information and their indexing will be stored with the master node. So HDFS layer will have all the information. So if you want to access any set of information, you can go to the master node and it will have all the record. You can go with the record and find out the desired information. Now, so Hadoop has a master slave architecture for data storage and distributed data processing. And it will use the MapReduce and HDFS method. Now we'll discuss some terms which is being represented in the Hadoop architecture. One is a name node. So let us go to the name node. So name node is basically related to the HDFS layer and it is located within the master node. So name node represent every files and directory which is used in the namespace. So it will keep the record of all the data blocks, all the files and the directory that is being created within the project. Second one is a data node. Data node is again available with the master node for the HDFS layer, and as well as data node is also created on the slave node. So there can be multiple data. So data node is designed to manage the HDFS node status and it allows us to interact with the blocks. So data node is basically responsible for communication with the data blocks. So it will act as an interface between the master node and a slave node. So basically when we install the Hadoop MapReduce on system, so we are creating a name node and a data node. So data node will be represented by the slave and a name node will be represented by the master. Now, master node. So master node allows us to conduct parallel processing of data using a Hadoop MapReduce. So you have to design master node. So if we will install the Hadoop MapReduce system, so you can find out there are two ways. You can install the Hadoop MapReduce on a single system or a multi-node system. When you install it on a multi-node, then you define one computing node as a master node and all the other node as a slave. But when you are working as a slave single node system, then the master node and slave node will be located to the same computing node, but they will act differently. So the main task of master node is to provide a parallel processing environment for data using the Hadoop MapReduce. Slave node. Slave node are machine which is located within the Hadoop cluster and it is basically used to store the information and as well as to the do the computation part. So when you are adding any system, your Hadoop MapReduce framework, whether it is being as a commodity computer or it is a dedicated system. So you are adding a computing capacity to your Hadoop MapReduce framework as well as you are adding the storage capability. Slave node comes with a task tracker and a data node. These allow to synchronize the process with name node and a job tracker respectively. So basically task tracker task is to whatever the application motive is, it will take those information and will divide the task into different jobs. These jobs will be assigned to different slave node and the task tracker will keep the record of all the jobs that is being processed by the slave node. And again, these jobs will be Output of this job and status of these jobs will be reported back to the master node. Hadoop master's slave system can also be set up in the cloud or on premises. So when we are installing the Hadoop MapReduce framework, it is designed to process large scale of information. So the main challenges with the Hadoop MapReduce is the devices. So if you want to increase the capability of your application, you need to add additional system. They will support you as based on the processing capacity as well as support you as a storage capacity. So if you are installing the Hadoop on your own premises within the college campus or within your home premises, your office premises, so it will incur you a lot of investment. So if you are not desire to do the so much investment, then you can take the help of cloud based services. So there are cloud based services which will offer you environment to install the Hadoop MapReduce framework, and they will charge you based on your requirement. So suppose at a time you will require n number of computing node or processing capacity, then you can request to the cloud-based services. They will give you the and devices support. At a time, if you require more than n devices support, then they will offer you the additional services on the marginal cost. And again, if you are not requiring n devices, you're requiring less than n devices, then again it will offer you a less number of devices and it will charge you based on that. So cloud-based services are very much helpful for those who is in the initial phase of their businesses, are developer who want to develop the application for any non-profit organization, or any developer who want to check their application that what is the performance of their application. So they can take the help of cloud-based services, and they can avoid to to invest a large amount of resource and invest into the large amount of resources, and it will also helpful for them because they are initial phase, they are in their initial phase, so they have some uh, cash problems, so they have some economical uncertainty within the businesses. So Hadoop MapReduce will offer you both way to install the system. You can install it within the premises, or you can use the cloud-based services. So these are certain features of Hadoop. It is suitable for big data analysis. So a big data is basically a distributed and unstructured in nature. So Hadoop cluster are best suited for analysis of big data. So what it does, basically Hadoop cluster is uh, collection of master and slave devices. So it depends on the application that how can it create the cluster of different devices. It is a processing logic that flows to the computer node. It will require less network bandwidth, and it follows the data locality concept, and it will increase the efficiency of Hadoop-based applications. So these are the features which is favorable to the big data analysis. And you can use these features to work with the to create any application that will work on the big data analysis. So as we have already discussed, we can develop application to process the text information. We can develop an application to process a medical information in a real time. We can develop application to process a weather forecasting, or you can news aggregator where you will take news articles from a different domain and you will aggregate those news based on your requirement, based on your motive, and after aggregating those news you can pass to your targeted users. So there are unlimited possibilities. What can you do with the big data analysis? And again, Hadoop MapReduce framework is open source, so it will open you another boundaries to include the Hadoop MapReduce for your project, and it will not constrain you from any perspective. It will not require any investment, initial investment. So you can adopt the Hadoop MapReduce framework. You can customize it as per your requirement, and you can develop your application which will purely based on the Hadoop MapReduce framework. Second feature is a scalability. So Hadoop cluster can easily be scaled to any extent by adding additional cluster nodes and thus allow for the growth of big data. So if we talk about the scaling, so when we are working with any organization, let us find out the e-commerce application. So whatever the traffic coming to the e-commerce application, it will vary with respect to the time. So you can find out that in the morning hour, you will feel less traffic, and in the evening hour, you will find more traffic. So when your traffic is increases for your website, it means you will require additional resources for storage and processing of those information. It is not feasible for low cost businesses to adopt, to buy up, invest in a new devices with respect to their businesses. So Hadoop MapReduce will provide you a feature which will take care of this thing. And by taking the help of commodity computers, community computers, or taking the help of cloud-based services, you can provide a scaling to your application by adding the additional devices within your Hadoop MapReduce framework. Fault tolerance, as we have already discussed, that a replica of data block is available within the Hadoop MapReduce framework. So it will overcome any type of failure of data. So what happens if you have any failure of data? So it will avoid you any type of loss of information. It will again make the system mostly working in a working condition, and it will uh, try to avoid any type of loss of processing capability. Okay, so that is all with the Hadoop MapReduce framework, and in the next session we'll discuss about the R programming language. So if you have any question answer, this session will be open for another 10 minutes. Okay, thank you for joining the session.